All right, so for 5.2, we're going to go ahead and cover factoring trinomials. I gave you a very, very simple definition of what a trinomial is, and that is typically where your polynomial or your expression has three terms in it. And so what it would look like, it would be in the form of ax squared plus bx plus c. This is just to show you that we have 1, 2, and 3 terms in a trinomial. Okay, and so when we're dealing with trinomials, we would have two different scenarios. For this video, it's going to cover going over trinomials where a equals 1. And when a equals 1, we're going to factor like normal. Okay, so what that means is the coefficient, okay, or the number in the front of your variable with the highest exponent, so your lead coefficient, is going to be 1. All right. The second scenario is where a doesn't equal 1, and we would use the MAC method, and that would be shown in the 5.3 video. Okay, so to recall, factoring is just reverse distributing or reverse FOIL. So to factor a trinomial, you're going to unfoil it, or you're going to do the reverse distributive property. So given this first example right here, we have x plus 2 times x plus 3. I'm going to go ahead and FOIL this out just to kind of show you what I mean by we are unfoiling it after. So FOIL, the F stands for first, so x times x. The O stands for outer, so x times 3, so x times 3. I is inside or inner, which is 2 times x. And then L means last, so 2 times 3. So if I were to simplify those out, x times x is x squared. We have plus x times 3, but I'm going to go ahead and put the 3 in the front. We got 3x. 2 times x is just 2x, and then 2 times 3 is 6. So how did I get these operations in the middle? So that comes from, okay, so 3 times x is a positive output. That's why I have a plus here. 2 times x is a positive output. That's why I have a plus here. Again, 2 times 3 is a positive 6. That's why I have a positive out here. So if, for example, you had a negative 2 times x, that again would change your sign to a minus instead of a plus. Okay, so after I did all of that, I want you to notice here, okay, notice that we have 4 terms. All right, but I know that y'all can clearly see that we can actually combine like terms. So I can go ahead and combine my 3x and my 2x together. And when I do that, you get x squared plus 5x plus 6. And so we started with 4 terms, and then when I simplified or combined like terms, I'm left with 3 terms, which brings us back to the trinomial. Okay, so after I FOIL that out, you got a trinomial as your answer. Now, when you are doing your quizzes, your homeworks, your tests on this, your problems are going to, again, be in a polynomial form. Your answers are going to be this factored form right here. So let me go ahead and show you the reversed order. Okay, so to factor or unfoil, okay, let's go ahead and go backwards. So I'm going to go ahead and take that trinomial that we just FOILed out. So x squared plus 5x plus 6. All right, and I'm going to go ahead and factor it or unfoil it. So when you do this, you're going to go ahead and look at your constant term, or the term that just has a number. Typically, it's the last one. And you're going to go ahead and ask yourself this. So what factors of 6 will add or subtract to give you the middle term? So to equal 5, which is our middle term right here. So I'm going to go ahead and split this up. So what two numbers would add to give you a 5? And so I'm going to go ahead and list out our pairs of factors of 6. So 1 times 6 is 6, and then 2 times 3. Those are the only pairs that we have for 6. And then you got to look between your combinations here. So which one would add to give you a 5? Well, I know that 2 and 3, if you add those together, you're going to get a 5. So filling in my blanks, we get x squared plus 2x plus 3x plus 6. All right, so again, I know that the 2x plus 3x will give me my 5x. And then if you can recall from 5.1, we have 4 terms right here. And whenever we have 4 terms, we are going to factor by grouping. So again, to factor by grouping, what you're going to do is you're going to place parentheses around the first 2 terms. So x squared plus 2x. You're going to place your second pair of parentheses around the last 2 terms and include the sign with it. So plus 3x plus 6. All right. Again, when you're grouping, you have to do your 3 GCFs. So my first GCF, or my greatest common factor, is going to come from here. So if I take out a greatest common factor between x squared and 2x, I know that x would be the greatest common factor. So x squared divided by x gives you x. All right, 2x divided by x gives you 2. All right, you're going to take your second GCF from the last 2 terms. So I can take out a positive 3 from both 3x and 6. So because I'm taking out a positive 3, I'm going to write a plus 3 on the outside. 3x divided by 3 is just x. 6 divided by 3 is positive 2. All right? And then again, when you're grouping, you want to make sure that these are the same. So I know that my x plus 2's are good, so I can rewrite it or take my last GCF of x plus 2. And then the last part would be what is left over. So again, we have an x and an x plus 3, and that's what I use to fill in the last set of parentheses. So here is your factored form of this trinomial up here. All right, so again, kind of just to zoom out of my notes, I just basically went in a circle. So I started with the factored form, I FOILed it out so that way you could see the trinomial. All right, I took the same trinomial, I factored it out so that way I could get my answer right here. Okay, so that is what you do. Again, factoring just means you unfoil or you do the reverse of your distributive property. Now, let me go ahead and give you another example. So let's say we have x squared plus 9x plus 20. Now, I'm going to go ahead and show you a more efficient way to do factoring because, and you can write this in your notes somewhere. I'll probably write it right here. The grouping process isn't always necessary. So grouping process is really not necessary every time you have a trinomial. Now, if you have a polynomial with 4 terms, yes, you're going to have to use it, but you do not need to do grouping every single time you have a trinomial like this. So here are some steps that you could follow when you're given just a trinomial, a way quicker way to do it. So you're going to look at your constant term. Find your factors of that term. So my factors of 20 are going to be 1 times 20. I know 2 times 10 gives me 20. I think it's 4 and 5. I think that's the only pairs. Okay? And then I want you to write this in your notes. So instead of having to group everything, you just have to ask yourself. So just ask. All right, so what multiplies 2? In this case, we have 20. And then you're going to ask, and adds up to your middle term, which in this case would be this 9. So we already listed out what multiplies to 20, and now among your combination of pairs right here, which one would add up to a 9? Well, I know 4 plus 5 will give me 9, so I'm going to use that pair. And let's go ahead and set up our pairs of parentheses. Now, when you're factoring, again, your factored out form should be in these parentheses. Okay, so we're going to have an x and an x here. The reason why we do that, again, going back to the unfoiling part, if I were to foil this out, x times x gives me the x squared. Okay, so that's why we have that there. I already decided that my numbers are going to be 4 and 5 because 4 plus 5 gives me the 9x. And then you got to look at your signs here. So this is plus and plus, so that means the signs in the middle are going to be plus and plus. So here is your answer or your factored out form for this trinomial. Again, to check yourself, let me do it in a different color, just so that way you know you factored it correctly. To check yourself, you can literally just FOIL this out. So to do that quickly, I know x times x gives me x squared, x times 5 is positive 5x, 4 times x is 4x, and then 4 times 5 is 20. Again, when you combine those together, you are left with x squared plus 9x plus 20, which brings me back to our original problem. Okay, so there is that. Let me go ahead and do one more example for you, just to kind of follow those steps. So let's say you have x squared plus 10x plus 21. Again, you need to take the last term or your constant term and find the factors of that. So factors of 21 would be 1 and 21, 3 and 7. I think those are the only ones that's there for 21. Again, set up your pair parentheses. Because this is an x squared, I know I have to have an x and an x over here. So we have x and x. Okay, if you look at your combination, which one would add up to give you the middle term, which is 10? I know 1 plus 21 doesn't give me 10, but I know 3 and 7 will give me 10. So I'm going to put my 3 and my 7 here. I'm going to use that combination. And because it is a plus and a plus, your symbols in the middle will be both plus and plus. Okay, so again, you can always check yourself by foiling, but I'm going to go ahead and move on. I want you to try these few problems here. So let's say you have this. So m squared plus 17m plus 30. All right. And then try this one, y squared plus 14y plus 45. Okay, so you can go ahead and pause the video and then unpause it after you have solved both problems. Okay, so to work out these problems, again, you're going to look at the last term or your constant coefficient, not coefficient, constant term. All right, we're going to list out your factors of 30. So 1 and 30, 2 and 15, 3 and 10. Let's see, 4 doesn't go, 5 and 6. I think that's it. All right, set up your parentheses. I know they're both going to have an m in the front because, again, m times m gives me this m squared here. And then you got to ask yourself, okay, which combination of pairs would give you a 17 if you add them? Well, 1 and 30 won't work. 2 plus 15 will work. So I'm going to go ahead and use 2 and 15. So 2, 15. All right, both symbols right here are pluses, so you're going to put plus and a plus. So there's your answer for number 1. Again, if you want to check yourself, you can go ahead and FOIL. All right, for number 2, do the same thing. Find your factors of 45. So I'm going to list those out to the side. 1 and 45. Let's see, 2 doesn't go into it. 3 and 15. 4 doesn't go into that. 5 and 9. I think those are the only ones. All right, again, set up your pairs of parentheses. We're going to have a y and a y here because, again, if you FOIL this out, y times y gives you the y squared. And now you got to ask yourself which combination would add to give you a 14. Okay, 1 and 45 does not work. 3 plus 15 is 18 and not 14. So I know 9 and 5 would work. So we're going to put 5 and 9. And then again, because it is a plus and a plus here, we are going to put plus and plus. So there is your answer for number 2. Okay, so a very important thing to note. So all of the problems that we have been going over, if you can recall or just notice, all of them had a plus in the middle. Okay, there weren't any minuses. All of it was just plus. So something to note that is very important. Okay, you need to make sure that you are careful with your signs, because it's not always going to be nice and easy like this where you're just going to go, oh, it's just plus and plus. All right, so your signs do matter. And I'm going to go ahead and give you a little cheat sheet so that way you can kind of see how the signs need to be placed. All right, so to give you an example, I'm going to give you 4 different scenarios because we will run into 4 different scenarios when factoring the trinomials when you have different signs. So to give you some examples of problems, all right, the ones we have been going over were the ones where you had a plus and a plus right here. So don't worry about the numbers right now. I just want you to pay attention to the signs. So right here, we're going to have x and x, plus and plus, and then 2 and 3 would be your numbers. So again, because we had a plus and a plus, well, your symbols in the middle are going to be plus and plus. All right, another example. Let's say you have x squared minus 5x plus 6. All right, look at this. This is a slight change, but we have a minus here instead of a plus. So here's how you would actually put your signs. So again, don't pay attention to the numbers just yet. I just want you to see that these are going to be the signs for it. If this term right here, if this operation is positive or a plus, your signs are going to be the same for these. You just have to pay attention to, is it going to be a positive or is it going to be a negative? So because this is a minus, you're going to have a minus and minus here. All right, and so for you to have this in your notes, again, when you are dealing with this, so when your constant, okay, so the constant term is going to be that last one right here. So when the constant is positive, okay, you add to get the middle term. All right, and so I guess another way to view it, when you are adding them, so again, when this right here is both a plus and a plus, you are going to have the same signs for them. So it would be, let me actually move this down a little bit. So again, we have the same signs here. So you're either going to have a plus and plus or a minus and minus. And that is dealing when this right here is positive. All right. So second scenario, let's say you have something like this. So x squared minus x minus 6 or x squared plus x minus 6. Okay, so again, don't really pay attention to the numbers just yet. I just want you to focus on the signs. So we have a minus and a minus. If that were the case, you're going to have a plus and a minus. So you're going to have 2 different terms. So x plus, x minus. For this one, plus and minus, you're going to have x minus plus. So I just want you to see here that the symbols are not the same anymore. And that's because we have a minus here. And so when the constant is negative, so when your constant is negative, you have to subtract to get your middle term. All right, so for here, 2 and 3, 2 and 3, all right, these are different signs. Forgot to put, so same signs. Here, you have different signs. And here, that is when, again, your constant is negative. So because these are different, so different signs, means you're either going to have a plus minus or a minus plus. Okay, so to kind of show you, again, this is just to refer back to your little cheat sheet here. Let's go ahead and go over a few examples. And I would really try to get familiar with this. So again, if this and this is a plus, depending on what this term is, will determine if you have a plus or a minus. All right, if the last term is negative, you just know that you're going to have two different signs. So, looking at an example real quick. All right, let's say you have x squared minus 13x plus 36. So you're still going to factor the same way. So we're still going to find our factors of 36. So 36, we got 1 and 36, 2 and 18, 3 and 12. What else? 6 and 6. I skipped a number. 4 and 9, I believe. Okay, so setting up your pairs, we have x and x. The combination of numbers that I want to add, because again here, this is a positive 36, so I have to add my numbers together. I know 4 plus 9 is going to give me a 13 in the middle. So 9, not 4. 4. And so here you have to be careful. This is a minus now. So going back to that cheat sheet, we have a minus, then a plus. If I go back up to here, well, we have a minus and a plus. So if that were the case, you're going to have a minus and minus. So to fill in your signs, minus and minus. And there is your answer for that example. Again, if you want to check yourself to see why the signs are the way they are, you're just going to have to FOIL them out. So again, if I were to FOIL this out, so we have x times x, which is x squared, x times negative 4, that would be a minus 4x. Negative 9 times an x gives you a negative 9x. And then negative 9 times negative 4, that's how you get that positive 36. All right, so again, using that little cheat sheet I gave you above is going to help you determine your signs efficiently and quickly. Let me give you another example using a different scenario. So let's say you have x, let's try this one, p squared minus 2p minus 15. All right, so again, pay attention to your signs. They're both minuses. If I were to go back up to my cheat sheet, okay, if I have a minus and a minus, that means I'm going to have two different signs, so plus and a minus. So continuing to find your factors of 15, we have 1 and 15, 3 and 5. I think that's it. All right, and so setting up your pairs of parentheses, p and p, because again, p times p gives you the p squared. And now you notice this is a minus 15 instead. So because this is a minus, you have to look at your combination and see which one or which pair would subtract to give you this right here, a 2. In this case, a negative 2. So I'm going to go ahead and put my plus and my minus here already. And so you have to decide, okay, well, I know that 5 minus 3 gives me a 2, but we have a negative 2 in the middle. So if I were to do 3 minus 5, that would work and give me a negative 2. So my 3 has to be positive, and my 5 has to be negative. Again, to check yourself, you can go ahead and FOIL it out. P times P is P squared. P times negative 5 is minus 5P. 3 times P is plus 3P. 3 times negative 5 is negative 15. Again, when you combine your like terms, negative 5P plus 3 is negative 2P minus 15, and we are back from where we started. So here is your answer for this one. All right, we did a minus plus, minus minus. Let's go ahead and do one more example, but in this time you have a plus minus. So let's go ahead and try this one. So x squared plus 14x minus 32. All right, so again, still utilizing this, we're going to find factors of 32. 1 and 32, 2 and is it 16? 16. 32 does not divide into 3. 32 divided by 4, we got 4 and 8. Does 32 divide into 6? No. All right, I think those are the only combinations. So again, setting up your pairs of parentheses, x times x. All right, so before you can even move forward, this is a minus. So, okay, we have a plus and a minus. So if you go back to your little cheat sheet for the signs, if I have a plus and a minus, I'm going to have these two terms right here. Or, I'm sorry, these two operations. So meaning we're going to have two different signs. Because again, you have to ask yourself, what can you subtract to give you a 14 here? Well, I'm going to go ahead and put my minus and my plus. So if I look at my combinations, 1 and 32 won't subtract to give me anything. Well, 16 and 2, if I do 16 minus 2, that will give me a positive 14. So you need to put your 16 here because it's a positive 16, and then minus a 2, so minus 2. All right, and there is your factored out form. Again, you can always FOIL out to check and see if you have the right answer. Sometimes you might have to do this just to double check, because what if you put a 16 here and then a 2 here, and this is just to double check your work. So x times x gives you x squared. X times 16 is positive 16x. Negative 2x times, negative 2 times x, I already gave you the answer, minus 2x, and then negative 2 times 16 is negative 32. And then right off the bat, we are back from where we started, and we are good to go with this factored out form. Okay, so moving on to the last few portions of 5.2. So sometimes the expression may contain a GCF. So again, if you can recall from 5.1, you always check to see if you have a greatest common factor first, always. So if you can factor out a GCF first, make sure you do that. So, for example, let's say you have 5y squared plus 5y minus 30. So instead of you listing out your factors of 30 from the get-go, you want to go ahead and check and see, do these terms have something in common? All right. I know that there is a 5 in common between each one. So if I were to take out a greatest common factor of 5 from every single term, your 5 stays on the outside, and then you're going to go ahead and just simplify. 5 divided by 5 is just y squared, right? 5 divided by 5, that cancels out, so you have y. And then negative 30 divided by 5 gives you a negative 6. So now after you take out your GCF, all right, you're going to go ahead and just do the same process that we've been doing. All right, this is just an additional step to what we have been doing. So listing out my factors of 6, we have 1 times 6, 2 times 3. Okay, again, look at your symbol right here. This is a minus, so I have to subtract these two numbers to get me a 1 in the middle. I know that 2 and 3, if I were to subtract it, it would give me a 1. 3 minus 2 gives me a 1. So you bring down your 5. It doesn't go away, it just stays there. Set up your pairs. Again, we have y and y because y times y gives you y squared. I'm going to go ahead and put my 2 and my 3 there, and then you have to decide, okay, what are your symbols? We have a plus and a minus. Again, going back to the cheat sheet, plus and minus means you're going to have two different signs, a minus and a plus. But then again, you have to check and see which one would work. I need a positive 3, because if I do positive 3 minus 2, you're going to get a 1 in the middle. So there is your answer for that one. All right. Last thing I want to go over. All right, so sometimes your trinomial could be prime. All right, so what does that mean if a trinomial is prime? That simply means that you can't factor that, so cannot factor. Now, not saying that you are not going to factor anything and say that something is prime. I still want you to check and see if you can factor it. But here's what a prime trinomial would look like. So let's say we got x squared minus 5x plus 12. So again, listing out your pairs of factors for 12. We got 1 and 12, 2 and 6, 3 and 4. All right. Because we have an addition symbol, we are going to find the combinations here that will add to give you a negative 5. So I'm going to go ahead and set up my parentheses, x and x. All right, so I have to add these combinations together to give me a 5. Well, 1 plus 12 is 13. That's not a 5. 2 plus 6 is 8. That's not a 5. 3 plus 4 is 7. That is not a 5. And so because none of these combinations work, that leads it to where this is not factorable. Okay, and so because it's not factorable, your trinomial is prime. All right, one thing I forgot to mention. Okay, so I want you to recall that when we were factoring these trinomials, so x squared plus 5x plus 6, well, when I factor that, we got x plus 2 and then x plus 3. Okay, you might have some problems where it'll look like this. So x squared plus 5xy plus 6y squared. All right, so that has two different variables. I want you to notice that when we factor this out, okay, you're still going to have to factor it very similar to how we've been doing to the other ones. All right, but now we're just dealing with two variables. So if I were to give you an example, okay, so let's say we got x squared plus 5xy plus 4y squared. All right, so right off the bat, I would go ahead and just set up your pairs of parentheses. All right, I know we have to have an x and an x here because when I FOIL that out, x times x gives me x squared. All right, now this is a plus and a plus, so I'm going to go ahead and put my pluses. And then the last thing I want you to note is that we have a y squared here at the end. And so because of that, you're actually going to put that last variable in the end. And so you're still going to go ahead and find the factors of 4. So we have 1 and 4, 2 and 2. Because we have to add them together, you have to look, okay, which one is going to add to give you a 5? Well, I know 1 and 4 would work, so that's what I'm going to use. So 1 and 4. So here we're going to go ahead and put a 1 and a 4. And that is it. Okay, if I were to give you one more example of how to do this, again, you're still factoring everything the same way that we've been doing. The only thing is we're just adding that extra variable at the end. Okay, so let's say if I were to work one more example, let's do this one here. Let's say you have v squared minus 11vx plus 24x squared. All right, right off the bat, I'm going to go ahead, set up my parentheses. Because we have a v squared here, you're going to put v and v. And then since we have an x squared at the end, you're going to go ahead and put x and your x. All right, after you have those set up, you can go ahead and find your factors of 24. So we got 1 and 24, 2 and 12, 3 and 8, I believe, 4 and 6. I think that's all of them. All right, since we are adding these, okay, because of that plus, we have to add these numbers together. But because we have a minus in the front, again, going all the way back to that cheat sheet real quick. All right, you have a plus here and a minus, which means you're going to have minus and minus. So that is already going to determine my signs for this last one. So we're going to have a minus and minus. And then now you got to decide, okay, which one's going to add to give you, 11 in the middle. All right, well, I know 21 and 24 is not going to work. 2 and 12 won't give me 11. 3 plus 8 does give me 11. So I'm going to use this one. All right, and then I'm going to go ahead and just place it, not 11, sorry, 3 and 8. And there is your factored out form for that one. Again, if you were to multiply this out just to check. So if I were to FOIL this, all right, v times v gives you v squared. V times negative 8x. So when you multiply this and this together, you kind of just put them together. There is no adding any exponents or whatever because v and x are two different variables. You're just going to just place them together. I would put them in alphabetical order. So v and x like this, right? Negative 3x times v, we got negative 3vx. And then the last one is negative 3x times negative 8, which is a positive 24x squared. All right? The reason why I want you to put them in the same order is because when we combine them, v squared minus 8 minus 3, that gives you negative 11vx. And then you can bring down your 24x squared, which is back from where we started. Okay, so there is that special case for that. I forgot to mention that previously, so I have to add that in. All right, and so here are a few practice problems that you're more than welcome to try out, so that way you can practice out these methods.